Burnout in electrical systems describes a condition where a component such as a receptacle, transformer, connector, or circuit breaker experiences such a severe overload that its contact surfaces overheat to the point of vaporization and subsequent fusion. This often leads to complete failure of the device and can pose significant safety hazards. While the term burnout isn't formally defined within the 2005 National Electrical Code, the NEC addresses the underlying causes and preventative measures related to this phenomenon through various sections. To understand how the 2005 NEC relates to preventing and mitigating burnout conditions, one should consider these key areas. Firstly, Section 110.14 focuses on electrical connections. This section provides requirements for making electrical connections to ensure they are mechanically and electrically sound. Poor connections are a primary cause of overheating, as loose or corroded connections increase resistance, leading to localized heat buildup. The NEC mandates that connections are made using approved methods and materials suitable for the application. This includes proper torquing of connections, using appropriate connectors for the conductor type and size, and protecting connections from environmental factors that could lead to corrosion. Secondly, Section 110.16 addresses the identification of equipment. While not directly related to the cause of burnout, properly identifying equipment with its voltage, amperage, and other ratings is crucial for ensuring that it is not overloaded. Overloading equipment beyond its rated capacity is a direct cause of burnout. Equipment should be clearly marked with its ratings, and these ratings should be carefully considered when designing and installing electrical systems. Thirdly, Section 210.8 covers ground fault circuit interrupter protection for personnel. While ground faults are not the sole cause of burnout, they can contribute to it under certain circumstances. A ground fault occurs when current flows through an unintended path to ground, which can lead to excessive current flow in other parts of the circuit, potentially causing overheating and burnout. Ground fault circuit interrupters are designed to detect these ground faults and quickly interrupt the circuit, preventing damage and protecting personnel from electric shock. Fourthly, Section 240.4b discusses protection of flexible cord and fixture wires. This section is crucial in preventing overcurrent situations that can lead to burnout. Flexible cords and fixture wires are generally smaller in size than building wiring and are therefore more susceptible to damage from overcurrents. The NEC specifies the maximum overcurrent protection allowed for these types of conductors, ensuring that they are adequately protected from excessive current flow. It is important to note that the overcurrent protection device, such as the circuit breaker or fuse, must be properly sized to protect the conductor it is serving. Fifthly, Section 250.3 focuses on grounding and bonding. Effective grounding and bonding are essential for safety and for preventing burnout. Grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices to quickly trip and clear the fault. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock and preventing the buildup of static electricity. Improper grounding and bonding can lead to circulating currents and voltage imbalances, which can contribute to overheating and burnout. Sixthly, Section 400.12 addresses flexible cords and cables. Specifically, their use is not permitted. This section outlines situations where flexible cords and cables should not be used, as these uses can lead to damage and overheating. For example, flexible cords should not be used as a substitute for the fixed wiring of a building, run through holes in walls or ceilings, or concealed behind building finishes. These improper uses can subject the cord to physical damage, strain, and overheating, increasing the risk of burnout. Seventhly, the code addresses busways and conductors. Busways are prefabricated electrical distribution systems consisting of bus enclosed in a protective housing. They are used to distribute power to various loads throughout a building. Overloading a busway or using undersized conductors can lead to overheating and burnout. The NEC specifies the ampacity of busways and conductors and provides requirements for their installation and protection. Eighthly, understanding overcurrent protection is essential to prevent burnout. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from excessive current flow. When an overcurrent occurs, the protection device trips, interrupting the circuit and preventing damage. It is crucial to select the correct overcurrent protection device for the application, ensuring that it is properly sized to protect the conductors and equipment it is serving. Ninthly, proper wiring methods are critical for preventing burnout. The NEC specifies approved wiring methods for various applications, taking into account factors such as the type of occupancy, the environmental conditions, and the voltage and current levels. Using approved wiring methods ensures that conductors are properly supported, protected from physical damage, and adequately insulated. Tenthly, regular maintenance and inspection can help prevent burnout. Regular maintenance and inspection of electrical systems can identify potential problems before they lead to burnout. This includes checking connections for tightness, inspecting conductors for damage, and testing overcurrent protection devices to ensure they are functioning properly. Addressing these issues promptly can prevent more serious problems from developing. The 2005 NEC provides a comprehensive set of requirements for designing, installing, and maintaining electrical systems to ensure safety and prevent burnout. While the term burnout is not explicitly defined, the code addresses the underlying causes and preventative measures through various sections related to wiring design, equipment protection, overcurrent protection, grounding, and bonding. It is important to understand and follow these requirements to minimize the risk of burnout and ensure the safe and reliable operation of electrical systems. Always consult with a qualified electrician or electrical engineer for specific applications and to ensure compliance with all applicable codes and standards. For example, if you are dealing with a specific appliance, it's important to refer to the appliance's listing and labeling information which specifies the electrical requirements. This includes the voltage, amperage, and any special instructions for installation and use. Ignoring these requirements can lead to overloading the circuit and causing burnout. Furthermore, the environmental conditions in which the electrical equipment is installed can also affect the risk of burnout. For example, equipment installed in hot or humid environments may be more susceptible to overheating. The NEC addresses these concerns by specifying dating factors for conductors and equipment operating in high-temperature environments. These dating factors reduce the allowable ampacity of the conductors to account for the increased heat. Also, consider the type of load that the electrical system is serving. Different types of loads can have different characteristics that affect the risk of burnout. For example, inductive loads, such as motors, can draw a large inrush current when they start, which can stress the electrical system. The NEC addresses these concerns by specifying requirements for motor circuits, including the use of overcurrent protection devices that are designed to handle the inrush current. Also, nonlinear loads, such as electronic devices, can generate harmonic currents, which can cause overheating in the electrical system. The NEC addresses these concerns by specifying requirements for harmonic mitigation. The use of surge protection devices is also crucial to prevent burnout from voltage surges. Voltage surges can damage electrical equipment and lead to burnout. Surge protection devices are designed to protect equipment from these surges by diverting the excess voltage to ground. The NEC recommends the use of surge protection devices in certain applications, such as in residential buildings and commercial buildings. To ensure the electrical system is safe and reliable, it is important to follow best practices for installation and maintenance. This includes using qualified electricians, using approved materials, and performing regular inspections. It is also important to keep the electrical system clean and free of debris, as dust and dirt can contribute to overheating. By understanding the causes of burnout and following the requirements of the NEC, you can minimize the risk of this dangerous condition and ensure the safe and reliable operation of your electrical system. Remember to always prioritize safety and consult with qualified professionals for any electrical work. The proper selection and application of electrical components are crucial in preventing burnout. For example, using receptacles and connectors that are rated for the appropriate amperage and voltage is essential. Using undersized components can lead to overheating and failure. Furthermore, the quality of the electrical components can also affect the risk of burnout. Using high-quality components from reputable manufacturers can help ensure that the electrical system is reliable and safe. Consider the effects of voltage drop on the electrical system. Voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause equipment to operate inefficiently and can also lead to overheating. The NEC specifies the maximum allowable voltage drop for various types of circuits. To minimize voltage drop, it is important to use conductors that are of the correct size and to keep the length of the circuit as short as possible. Understanding the concepts of impedance and reactance is also important in preventing burnout. Impedance is the total opposition to current flow in an alternating current circuit. Reactance is the opposition to current flow due to inductance or capacitance. Excessive impedance or reactance can cause voltage drop and overheating. The NEC provides guidelines for minimizing impedance and reactance in electrical systems. Finally, consider the impact of energy efficiency on the electrical system. Energy-efficient equipment and practices can help reduce the load on the electrical system and prevent burnout. For example, using LED lighting instead of incandescent lighting can significantly reduce energy consumption. Implementing energy-efficient practices, such as turning off lights when they are not in use, can also help reduce the load on the electrical system.